Hello dear students. So this is our next lecture on this complex analysis. So in our previous topic we have discussed about that what are basically the analytic functions and what are the basic criteria for a function to be analytic. So we need to check whether that CR condition is verified or not. So if this Cauchy-Riemann conditions are satisfied, so then we are saying that that function will be analytic, right? So if you are new to my this channel, so just visit my previous videos, so where it's clearly explained that so how to check the analyticity of a given function, right? So that means for a function to be analytic, so this Cauchy-Riemann condition should be satisfied, or we can say that it should be differentiable within the neighbor of some point, and it should be differentiable at that point itself also, right? So this was all about this to talk about the analytic function. So in short, you can say that an analytic function is simply the differentiable function, which is differentiable, right? Now, our today's topic is about that Cauchy integral theorem, right? So it says that if we consider that if we have some domain, we have some set of points in our complex plane. So we're saying that our function can be, it will be an analytic function in a simply connected domain. So that means our function is differentiable within the given this domain. Okay. And we consider that if we consider any point here. So if we consider any point z0 here, right, which encloses this loop C, right? So we can say that for this point z0 in B and for simply closed path that encloses this, it ensures that if you calculate the integral over this region, right, is that's integral over f of z dz divided by z minus z naught, right? So this comes out to be 2 pi I into f of z0. So that means we have this function will be analytic except at point whenever z equal to z naught, because when you put that z equal to z naught, so our function will not be analytic at point z naught, right? So rest in the neighborhood, so it will be analytic in that case, right? So for that case, we are saying that this integral should be 2 pi I into f of, right? Or we can say that our that f of z0 will be equal to this one by dividing that 1 by 2 pi r. So this is our that Cauchy integral theorem, right? So let us use this Cauchy integral formula, for some problems. So we evaluate some of the integrals with the help of this formula, Cauchy integral formula, right? So first is that if you want to evaluate this integral, right? And so we have this closed integral where C is, right? So we have C is a circle, that closed path. So this is a circle with mod of z equal to 2. So that means we have this our complex plane, right? Because so this will be that x square plus y square equal to. So that means we have the circle with center at origin, but radius equal to 2, right? So this is mod of z equal to. Okay. So that means first we need to check. So let us check. So where the function will be, where the function is not analytic, and so we need to check that. So if we consider that, so we can say that let us solve this integral first. So we can write this I will be equal to, right? So this function, if you say that this function, this fz, so it is not analytic at z equal to 0, right? So how? Because when you put that, so here that z equal to 0 is clear, and second when you put that z square plus 1 equal to 0, right? So that means at z equal to 0, our this it will be 1 divided by 0, so this will be, it's not determined at that point, so that the function will not be analytic at that point. And similarly, if you put that z square plus 1 equal to 0, so you can have that z equal to plus iota or z equal to minus iota. So in both the cases, so you can, when you put z equal to plus iota minus iota, so in that case our function loses its analyticity, right? So we can say that our function f of z will not be analytic in that case, right? So let us solve this. So now we can write that f of z will be equal to. So we can write that. So this integral will be equal to. So our cos of this f of z will be equal to then. That will be cosine hyperbolic of pi into z. Right? And this you can write as. So you can write this as cos of iota pi. Because you can write that cosine, you can convert cosine hyperbolic function, you can convert into cosine by multiplying by iota pi into z. Right? Okay. So we can write them. So our integral will be in that case. So we can write that our I will be equal to. So that's equal to. Okay. So let us use a partial fraction because we need to split this. So we can write that 1 divided by. So this I can write by. Or so better is to write in this way. That's 1 divided by. Okay. So this will be equal to. So simply use that partial fraction here, method of partial fraction. So this will a by z plus b by z plus iota and c divided by z minus iota. Okay. So you can use that. So you can write this as. So you can use this as. So this will be 1 will be equal to. It will be equal to a into z plus iota. Okay. Now you compare the coefficients of first. You compare the coefficients of that. First you compare the coefficients of constant term because this will be a into z square plus 1, right? So when you compare the coefficients of constant term, so a will be equal to 1. Okay? Because when you compare that here, because this will be z square plus 1, right? So okay, let me write it this way. So it will be that z square plus 1, right? Plus b into z minus 1 iota. Now we compare here coefficients of constant terms, right? So that means a is equal to 1. So first, and similarly, compare the coefficients of z square terms, right? So when you compare coefficients of z square, so this will be 0 will be equal to a plus b plus c, right? And similarly, now compare the coefficients of this iota. Compare the coefficients of z here, right? So that means you can have them 0 will be equal to, that is minus iota b. Uh, sorry, what I did here? So we can write this as, so because this will be that b plus c, right? So that means b equal to minus c and a equal to 1, right? So when I use this condition, so that means our a equal to 1 and 0 equal to b plus c equal to 0. So that means we can have this 1 a equal to 1. So what I get here, so just check it. So if this is, so sorry, so this is, we put that z square, this a plus b plus c, and when you compare their coefficients, now compare the coefficients of z. So compare the coefficients of z will be, so it will be, because this will be minus y, so this will be minus, right? So this will be minus b, because iota will cancel both sides. It will be minus iota b plus iota c, right? I can write this way. Okay, so you can put it this way. Okay, so just one more step is that is 0 will be equal to, that is minus iota b plus iota c. Okay, or you can write this as, that is b plus c. B plus c equal to 0, that is minus b plus c, right? So that is, you can get here when b equal to c, so this is plus 2c, or c will be equal to 1 by 2, and b is also comes out to be 1. So just substitute this, so you will get that b also equal to, sorry, c will be, this will be minus 1 by 2, it will be minus 1, right? So just check that, because यहाँ पे आएगा that c will be minus 1 by 2, and similarly you instead of that b equal to minus c, and put then the c equal to plus b, right? So in both the cases you will get that, you will get b as well as that c value, right? Now we use this in our equation, so we have this integral, so just check this integral. So I have this integral, so that's integral f of z dz, so we use it here, right? So we can write this as closed integral, that's f of z, into that's a is 1, that's 1 by z, that is minus 1 by 2 into, okay, okay, or you can write this as, because you just check, तो यहाँ पे अगर हम देखेंगे, so if you remember that, so because our circle is, we have this, so just check this one, so we have this circle, right? So these are basically that these imaginary values, so this will be 1 iota, and this will be 2 iota, right? And this will be minus 1 iota, and this will be minus 2 iota, right? तो अगर ये पॉइंट चेक करेंगे, जो हमारे पॉइंट्स यहाँ पे है, because z equal to plus iota and z equal to minus iota, right? Because z equal to here plus iota and z equal to minus iota, so they will lie, within this thing, because z equal to plus iota is this 1 iota, and z equal to minus iota is this thing. So that means a point is, they will lie within this zone, right? Okay, and even z equal to 0, because we can put that z equal to 0, so this will lie within that closed path. Even we have this z equal to plus iota or z equal to minus iota, this will also lie within the closed path, right? So we can check that. Then, so we can write them. So we can solve this integral then. So this integral will be equal to. So we can write this as. Okay. So what would be this value? So you just remember that. So we have this. If we have this the integral for closed loop, that's f of z. So we can write that. We have this. If you have the integral of this form, that is uh, uh, dz upon z minus z0, so that will be equal to 2 pi, right? Okay, so So that means this integral will be equal to, because our m will be minus 1. You just check my previous video, we have solved this, that when m equal to minus 1, we are getting that 2 pi I, right? And so we can use it here. So this will be equal to, so I can use, so this will be simply that 2 pi I and f of z, but we need to put that when z equal to, so you need to check that our z should be equal to at z equal to 0, right? Okay. So you can write this as, so this integral will be equal to, so first will be 2 pi I f of z at z equal to 0, because this point z equal to 0 lies within the circle, right? And similarly we can have z plus iota and z minus iota, because our circle is, that is mod z equal to 2, so we have that, we have the circle of radius 2 with center 0 0, right? So that we do include all these pointers, either it can be z equal to 0, or it can be z equal to plus 1, or z equal to minus 1. So it will include all those points, so we can check the analyticity within this region, right? So we need to solve this integral for this, right? Okay. So first is this thing plus that 2 pi I into 1 by 2, or better is to write this way, because so you can write it this way. So that's 1 by 2 into 2 pi I, and so is it plus 1 by 2, or so this is minus 1 by 2, no? Minus 1 by 2. So this will be, so this will be minus, so this will be minus. Okay. So this is our integral, total integral. But remember that. So what's our f of z? So you just check that. What's our f of z? So f of z is basically cosine cos of iota pi z, or you can take the cosine hyperbolic function pi of z. So I can write it this cosine hyperbolic in terms of cos by multiplying that iota. Huh? So that means we need to check that this value at z equal to 0. So that means this will be, can add that 2 pi I into, better to write this. Okay, so this will be that. Okay, or this will be equal to, and you'll get here when z equal to 0, it is cos 0, that's equal to 1, right? We'll get here 1 minus 1 by 2. And what about this? If you put that, this will be z equal to iota, this is iota square pi, it will be cos of minus pi. And similarly, this will be again that cos of plus pi. So this is cos of minus pi, and this is cos of plus pi, right? So this will be equal to simply that. So this will be, it will be minus 1, so this will be plus 1 by 2, and this will be plus 1. Because we will get that cos of minus pi and cos of plus pi, right? Because z is equal to plus iota and z equal to minus iota in this term, right? So when you calculate that cos of this minus pi and cos of plus pi, so you will get that minus 1 and plus 1, minus 1 in both the cases. So this will be plus 1 by 2 and plus 1. So that means our integral will be equal to, so this will be simply pi r, right, into 4. So this is the how you can calculate the integral in a complex plane. If we have some closed path with well defined that circle, with well defined that radius and the location of that circle, right? So we can use it with the help of this Cauchy integral formula, right? Similarly, I will give you one more with this problem on this. If you want to evaluate this term, so for example, You want to evaluate. That means we have some circle half radius 3 here, right? So that means our circle will be, it will be this 3. Okay. So that means we can say that first. So let us check that whether the function. So this function will be, it will be not analytic at z equal to, because अगर हम z equal to लिखेंगे, so this integral will be 0. So that means the function will not be analytic at z equal to, because we have some circle having radius that's equal to 3 and which is located at the center, right? With the center as the origin, right? Now we can write this as, so that means we can write this as integral will be equal to that e power z, right? Okay. Now, so we can say that this function f of z is not analytic at z equal to. So that means अगर हम z2 लिखेंगे, if z will be equal to, so in that case our function will not be analytic, right? So that means we can write here, so our f of z will be here, that will be, so that will be equal to p of, right? Okay. Then use that Cauchy integral theorem, Cauchy integral formula. So we can write that integral e power z, right? We already know that if you take the integral of that 1 divided by that z minus 2 dz, that's equal to 2 pi I. So it hardly matters. So it hardly matters whether our center will be the origin or it can be somewhere else in the complex plane, right? Like if we have this, so we have some circle, so this is our xy plane complex plane, right? You are saying that we have some circle, some closed path, but with this z0 is our 2 here, right? So z0 is somewhere, it can be somewhere, you can see that it can be somewhere here, z0, right? Okay, right? So we can say that the circle can be anywhere. So it can be anywhere because our z0 is equal to 2, right? But overall the value of this integral, the closed path for this closed integral, so that's equal to 2 pi I. Or you take this instead of that, you can take it as a center. So center latest value will be same. This is basically what that Cauchy integral theorem tells us, right? Okay. So you can, but provided that the function is not analytic at z0 itself. तो हम कहते हैं कि जो हमारी function की analytic नहीं होगी at z0. But outside that domain within this region, so it will be analytic and also on the closed path, right? So this is what I wrote here. So instead of that 1 divided by that, when you take the integral that 1 divided by z minus 2 dz, so that will be equal to 2 pi I, right? So you can write this as, so this will be equal to that 2 pi I f of z, and check that, because when you consider that mod z equal to 3, so you have that, because our circle is, we have some this circle with radius 3 here, so but z equal to 2 lies within this circle, so that means it lies within this domain. जो हमारा value है, so it lies within this domain, right? So in that case, so this value will be equal to at z equal to, right? So this will be equal to that 2 pi I e power z and z, right? So that's equal to, And similarly, so I can show you one more problem. Like if we have this, if we want to solve this integral, we have this one more example. All right, it is z minus 2. Right? So you can do it. So better is to, okay, so let me write, because this is very easy. So you can do it yourself, right? So let's stop that. If you have some, because this is very easy. So you can do it because it's very easy, because I already showed you some of the problems similar to this thing. So you can do it, right? So better is take some new problem. So you can take that if we have this function. That's e power az. So if we take this function, right? And while c is an ellipse. So that is to take, because that's why. So I basically take another problem. So that is a bit different from this. So where c is an ellipse, right? Okay. With the condition that z minus 2, that's equal to 6, right? So while c is an ellipse, तो हमारा ellipse है यहाँ पे, right? With this condition, right? So we need to check that, we need to solve this integral, right? So before solve, so we need to first this first calculate this. So check the this ellipse where it lies. So because we need to check that whether the function will be, if you put that z equal to iota pi, whether that point will lie within that sort of closed circle or not. So for that case, तो उसके लिए हमें क्या करना है? First we will solve this, right? So we'll write that, because our z is our complex number, you can write it in terms of that x plus iota y. Then we can see the form of that ellipse, where it lies in our complex plane, right? So we need to check that. So let us rewrite this. So because we can write this as here, the z minus 2 plus that's equal to 6. Okay. Or you can write this as, so this will be equal to that x plus iota y. That's equal to 6. Okay. Or you can write this will be equal to, okay. Or equal to 6. तो यहाँ पे मैंने क्या किया, I simply wrote that x equal to that z equal to x plus iota y, then I combine those real parts, that's x minus 2 का whole square plus y square raised power 1 by 2. So that's how we define the modulus, right? And similarly the second term, that's equal to 6. Right? Now we do one thing. So you just put this term to over that right hand side. Okay. So that means I can have this. Now you do squaring on both sides. You square this. So squaring on both sides. Okay. So you can write this as. Is it okay? Because so what I did here, I simply do squaring on both sides. So our left hand side is because we have square root. So this will be simply that x minus 2 ka whole square plus y square, right? And similarly, our left hand side will be, so that is, we'll get that 36 plus this term because square, then twice a b, yeah? Minus 2 into a into b, right? Or you can do one thing now. So, so you can take this as, because we have this, okay, let's evaluate this. So this will be x square plus y square minus 4x, right? Okay. So is there anything else? Should that? Okay, so this will be equal to 36 plus. Okay, so this is it. So simply I do some algebra here, right? And rest is here. Now this x square, y square. So this will cancel on both sides, right? Or you will get that. Okay, so you write this as. Okay, so you write this as. So you put this minus 12. That minus 12. You just put it on the left hand side, and whatever is on our left hand side, that's minus 4x. You put on the right hand side, right? So first you write that. So this will be that 12 into. That's equal to 36 plus 8x. Okay. Now, so we can do one thing now. We can, okay, is there anything else? So there's one more term. So I basically forgot here because we have here. So यहाँ पे और एक term रहेगी, that is, that will be plus 4 here, right? Because, and similarly we have one more term here. So that will be equal to, okay, that is to write this. So we can write this way. We can write this as x square. So that's equal to, so you put here 4 plus, huh? Okay, right. So, so instead of that, you can write that this will be 12 into x plus 2 ka whole square, and this will be here because uh, okay. So what else I will get here? Okay, 36, 36 plus 8x. So that's 12. Okay, that's right. So because this will cancel on both sides, so that's it. So ये cancel भी हो जाएगा, so this side. Now you can write this as, because this will be equal to, you divide that 4, so this will be 3 into. Now again, because we need to simplify and because we need to see the form of the ellipse, because we have that ellipse, if you remember that, so as I already wrote here, that C is an ellipse with that with this form, in this form. So we need to simplify it and see the form of the ellipse and where it lies in our complex plane, right? So first, so it's okay, right? Now you do again. So again you squaring. So you write squaring on both sides. So that will be equal to 9 into, right, and that's equal to 81 plus. So let us check whether it is right. So we have to check करेंगे यहाँ से, because when you do squaring, so this will be 9 into, because this is square root, so this will be 9 into, that's x square plus y square plus 4f plus 4x, and because this root will cancel, and our right hand side this will be 81 plus 4x square plus that is 36 x, right? So this is what I wrote here, 36 into x. Okay. Again, so what we do here, so this will be 9x square. Okay. So this x square, this will be, okay. You can write this as, because this will be 9, this will be 4x square, so this will be minus 4, this will be 9 minus 4, that's 5x square plus 9y square and this 36x. So ये cancel हो जाएगा, and this will be equal to, because you put that 36 on our right hand side, so this will be 81 minus 36, that's 45. Or you can write this as, this will be x square divided by 9 plus y square, right? So this is a form of ellipse, right? Because the equation of elliptic ellipse is that x square by a square plus b square. तो हमारा जो ellipse होता है, it is in this form. So x square by a square plus y square by b square is equal to 1, right? So that these are our a and b are our semi-major and semi-minor axes, right? So that means जो हमारा a होगा यहाँ पे, so we can rewrite this as b square plus, जो हमारा ellipse है, it is of this form. So let us plot that. Okay. So first is that is our this ellipse, so that means जो हमारी semi-major axis है, that is 3. So that means it will be 3 here. That's 1, 2, right? And our y-axis, semi-minor axis, our that's 2.2. So 2.2 is, suppose this is 1, this is 2, and this is 3. So it will be somewhere here, this point, and that point. So it will be like this. Again, this is 3 here. Again, this is 2.2. So this will be minus y minus, right? So this is the form of the ellipse. Very ellipse simple, because so from this equation, so after solving that condition that z minus 2 mod of z minus 2 plus mod of z plus 2, that's equal to 3. So after simplifying that, so we are basically getting an ellipse with that a equal to 3 and b equal to 2.2. Right? So this is an ellipse, right? So let us check our that condition, because what was our equation? So if you remember that, so जो हमारी equation थी, so this is our equation, that is this thing. So that means जो हमारा f of z यहाँ पे है, so let us check that. Just put one more, so you can have that integral equal to, that is e power a z dz upon, is it that z minus z upon, right? So that means जो हमारी जो integral होगा, the function will be, it is not analytic at z equal to iota pi, because उस time हमारा जो integral 0 बन जाएगा, so it will be right. Now, so we can say that at z equal to pi, it's not analytic, right? So that means f of z will be equal to, and this sorry, so this z equal to iota pi. So that means जो हमारा z equal to iota pi होगा. So if you put that z equal to iota pi, so this is some 3.14 iota, right? Because अगर हम z यहाँ पे देखेंगे, so that is it lies outside that one, outside that circle, because our circle, that eclipse, sorry, our eclipse is, we have this 2.2, right? But this becomes 3.14 iota, so it lies outside that domain, right? Because so it should lie within that domain, so it lies outside that, right? So that means जो हमारा इंटीग्रल होगा यहाँ पे, so that will be equal to, so that will be equal to, because we can say that this will be simply equal to 0, right? Because this point should lie within that domain, because it's not, it's lying outside that, right? So then we can say that this integral will be equal to, right? So we can solve some more problems on this, like if we have this. Okay, so like if we have this, you can take some another this some integral, but the important condition is that so whatever the point where our function is not analytic at some specific point, so that should lie within that domain, within that closure. So यहाँ पे क्या होता है? It goes basically outside that eclipse, right? So that means the integral will be in that case that equal to 0. That will be equal to 0, right? So hopefully in our coming lecture we'll do some more problems, and we'll do some, if you take the derivatives, higher derivatives of so analytic function, right? So hopefully we will discuss that in our coming lecture. Thank you.